Hello geometers and general seekers of truth. Welcome to the continuing series of videos here on other lengths of segments inside and outside of circles. And the same strategy will apply now as we did before, which is to make similar triangles. Okay? And in particular, we want to make congruent angles based on the picture that we're given. So hopefully you've at least attempted this, and maybe you've hit some dead ends, but that's okay. The same thing happened to me, but now I'm going to present to you the solution that I know will work. So if I draw that line in there, one thing that it's clear in this picture is that angle A is 1/2 of arc DE. Okay? And I'm not going to write down all the reasons this time, just to speed things up a little bit here. Okay. And if we try to make another triangle this way, you can see that angle C is also 1/2 of arc DE. Well, then we can conclude that angle A and angle C are congruent. And this is by the transitive property. Now I want to point out that many of you have, maybe if you honestly tried this problem, you try to connect A and C, you connect D and E, but the issue with those types of approaches is that you don't end up with inscribed angles. So I guess another idea to this lesson is to use inscribed angles as much as we can in order to produce similar triangles. Okay? And if you look at this particular picture, angle B, so we look at the blue triangle, that has angle A, E, and B. Okay. And if we look at the red triangle, that has angle C, which is congruent to A, D, and then B. Now, the nice thing about using these two triangles is that they share angle B. So I should write a little note here that angle B is really congruent to itself, and this is really the reflexive property. Therefore, from these two facts, we know that these two triangles must be similar to each other. Okay. And then from here on out, we can fill in some of the missing pieces, some of the givens that we have, and then solve for whatever is left. So BD is 3. That's 3. AD is 8. That right there is 8. And BE is 5. And EC is this length here. That's the thing we're looking for. Okay. So this here is also some theorem in your book. I'm not sure which theorem number it is. I think it's 10.15. But again, whatever theorem number is really not relevant in this case. What matters is how we are able to get to this point and then use it from here on out. So we're going to set up some proportions. Let's see. We're going to need to use A. We don't want to use AE because we don't know anything about it. Rather, what we're going to use is AB. So that corresponds to CB. And then we're going to have to use EB. And that corresponds to DB. Okay. Then we make the substitution. So AB is 8 and 3, so that's 11. CB is 5 plus X. EB is 5, and DB is 3. So from this point on, we do cross multiplying. You get 33 is equal to 25. This is really 5 times 5 plus x, so 25 plus 5x. Subtract 25 from both sides, we get 8 equals 5x. Divided by 5, we get 8/5 equals x. Or you could also write this as 1.6 equals x. That would also work as well. Okay. So, again, find congruent angles, find similar triangles, and then use proportions. Okay. So we started out with a problem from the previous video. Here's a similar one. and I challenge you to solve the next one on your own. Same strategy, just got to work at it a little bit more this time. Thank you for watching. As always, ask your teacher if you are still struggling, and have a wonderful day.